Hi, my name's Aaron Manzano, and I'm here to talk to you a little bit about data analysis industry standard procedures, as well as time series analysis, some main principles of data ethics, and talking about bias in data, specifically measurement bias, as well as regression and classification tasks and how they differ. So, first, we live in a world of big data, and this data is um, huge and growing quickly. So, this is hours of video uploaded to YouTube every minute. And for the past 3 years, we're up around 500 hours per minute. So, this is what it's like living in a exponentially increasing data centered world. Um, and it leads to a lot of calculations like this. So, all signs point to this trend continuing. So this is big data revenue worldwide for the this decade by major segments. So data is going to be increasing as well as the share of revenue in billions of dollars. Um, so in the early part of the 90s, the CRISP DM was created, cross-industry standard process for data mining, and this has to do with basically keeping all of the practices in a line that we can show here, all concerning data. So as you can see, the data trends are incredible. They're taking off. And what do you do with them? Well, we have to start with business understanding and data understanding. This is basically the business people and the data people talking coherently. So this has a lot to do with interpersonal skills, making sure the business and the data people are both on the same page. Um, Once you get through that, and you're on the same page, you can start to begin data processing. This is where data is cleaned, checked for measurement bias, checked for consistency, negative values, or null values, and generally getting ready for modeling and evaluation, which are two steps. So there's 6 steps. Here are the first 5: business understanding into data understanding. Then you have data processing. Now, modeling and evaluation are in a cyclical loop here because the modeling and evaluation are going to be almost part of the same step. This is really, really important for making decisions and eventually deploying this data. Now, you notice deployment has not only um, relationship with the evaluation, but it also, the evaluation has to be brought back into business and data understanding in order to um, effectively deploy the model, which also needs evaluating, because no matter what data you have, it's not sufficient. Real world data is going to be always surprising and always have outliers that you'll have to deal with evaluating the deployment of whatever model. Um, so yeah, basically this is the 6-part CRISP DM method for data mining, and it keeps everything together as far as having a game plan for keeping models, creating models and make decisions in the real world with big data. So part of modeling also includes time series analysis, which is here just the stock market. So as you can see, time series, you have months into years on the x-axis and a price. So time series, this is all correlated by trading view, but part of the big thing about time series is collection, pre-processing, and then you can have some exploratory data analysis. But the collection is basically gathering timestamp data. Pre-processing is handling missing values or outliers. Could be smoothing the data as well. And then you can start doing exploratory data analysis, which basically involves some kind of prediction or understanding that the data can give you about the real world. So some of the main principles of data analysis ethics, they can all basically be fit into here. So you have a lot of ethics as far as communication up here with the interpersonal skills of the business and data people coming together for understanding. But a lot of the data analysis ethics has to do with data processing. Um, so this is where you want to be sure of customer privacy. Um, you want to have accountability in everything that you're doing here to make sure that any bias that could come through can be easily identified. Um, and yeah, exactly. So then it goes into modeling and evaluation. So you want to be careful about bias when you're talking about ethics. So there are collection biases. This has to do with up the stream from the processing, but data collection, which would really be in here. Collection bias. So basically, data gathering. Is there something wrong with the data gathering? Is there something wrong with the sampling? So a lot of times you're processing just a sample of the full data. Are you doing that in a truly random way, or are you um, somehow biased in what or how you're sampling? Exclusion bias. So this has to do with again with it's kind of in between sampling and collection. What are you ignoring? Are you ignoring an important part of the puzzle here? And then measurement bias is something, some data, or is it wrong, or is it something that you could increase the accuracy with which the tools are measuring the data? Um, and then there's also presentation bias, which typically has to do with in here in the interpersonal way, you can skew the data to fit what you already think, etc. So ethics definitely has to do a lot with bias and making sure that the bias is somehow mediated or at least identified and curtailed in some way. So next is, so a specific way here addressing specifically measurement bias. So one thing that could go wrong is if in a financial setting, you're looking at inconsistencies in data, which could be due to things like currency displacement. There's different currencies, and you want to make sure that you're on one standard, that you're not measuring in Argentinian pesos and then doing some other modeling in the relative dollar amounts. And one way to raise a concern with management is just to be completely upfront, because you're going to need to voice the concerns and get that in data in writing to be able to take proactive steps to detect and voice concerns. So there are corrective measures, there are fairness aware, so-called fairness aware algorithms, and continuous scrutiny is always needed in order to basically champion fairness and accuracy in all of these predictive analytics. So finally, with the difference between regression and classification, that would go on in the modeling and steps. But regression is basically trying to predict a continuous variable. So something like housing prices, income amounts, any kind of probability, depending on the probability, I suppose. But then you have classification, which is better for picking a quantifiably different category. So something like the binary classification of will a loan be approved or not? Will this drug work or not? And those kind of things where there's a 0 or 1 or multiple different categories where you'll have to put a customer into a certain profile bracket and such. So those are the two main kinds of models here, and they have their own kinds of evaluation, but they have specific deployment needs. So regression and classifying differ in that way. Yeah, so I hope you enjoyed everything, the presentation, and have a great day.